Hello and welcome to everybody. So in this video we will discuss that how can we model the FRAP data, that is the fluorescence recovery after photobleaching data, into a drug diffusion equation or a drug diffusion model. So for that, first of all, this is our raw data. So we need to get more number of data points in order to fit this particular data into a model equation, and for that we will use the concept of interpolation. So first what we will do, we will remove this particular row and then we have to find out the minimum value. So here in this case the minimum value is this one. So what we will do is we will copy this entire data, not the entire data, there is a minimum 10 points from the minimum value. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Control C. Okay, we will go to origin and then we will go to control V. So we have pasted the data. Now what we will do, we will select these two rows. Okay, we will go to analysis, mathematics, interpolate or extrapolate, and then we will go to open dialog. Now here we will use the concept of the cubic spline interpolation. So here we will uncheck this auto and we will use the cubic spline. So the more number of data points, the better will be the modeling. So here we will use 100, let's say, and the output will drag down, and here we will simply write as mu, because we want both x and y to be interpolated. Okay. So first we will do auto preview. Now it's very important to note that we have to choose the data points in such a way that the black line represents the main equation line, and this red line or the interpolation line, they have minimum deviation among each other. So if we say, suppose if we give 200 data points but the deviation is very large, but if we give suppose 50 and the deviation is small, then we will consider that 50 itself, and the number of points should not be less than 50. Okay, so now we will click on OK. So we have got this interpolation part. So what we will do, we will simply select it, copy full precision, and then we will go to here. So I think we have to again copy it. So let's right click, copy full precision. Okay, and then we will go to here Excel file. We will simply paste it here. Okay. Now the thing is that this represents your time data, this represents your intensity data. So what we will do is we have to make it as 0, because the FRAP experiment starts from 0. Therefore 0, then equal to time data. That is, we will calculate here the del t value, del t, this one minus this one, enter, equal to, in the third cell we will write as this particular cell plus this one, and then we will simply do F4, then F4 will be fixed. Okay, and then we will do enter, and then we will simply double click to get the values. So this now represents the time value. Now we have to also do like this whole self. What we will do, 0, no sorry, equal to this one minus this one, 0, then equal to this one minus, we have to fix this particular cell. So again we will do F4, enter, and then okay. So now this is my interpolated data. This will be not required, therefore we will delete the columns. But what is happening, as the formula is depending on those values, we will simply do Ctrl Z. Okay, and we will select them, we will do copy, again we will select them, simply paste the values. Okay, now we can delete it without any problem. Okay, this represents your data. Now we will mainly model the initial part, that is 6 data points, 1, 2, 3, 4, 5 and 6. So Control C, and then we will go for Control V. Now with these data points we will have to model this particular data into the particular equation that I will show you in JMP software. So we will go to JMP software, this window will appear and we'll go to the new data table. Okay, so the data table will come out. So in the first column we will double click and we will write small t. Similarly, in the second column we will double click to write the I means intensity. Okay, so what we will do is, the first thing will be to simply copy this data, Control C, and then we will go to T, Control V. So this represents your interpolated data. Now in the third column we will write as KP model. So KP stands for the Kochmeyer-Pepper's model. Okay. Now we will do the right click, formula, clear, and then we will have the parameters. Now we will write a formula according to the papers. So the formula for the Kochmeyer-Pepper's model is, what we will do, capital K into bracket small t to the power n, where k is the diffusion rate and small n is the diffusion constant. So simple, we will just enter. So we have done it. Now we will go to constants. On the drop down arrow we will go for parameters. Okay, let's say new parameter we have select k and n. So k, let's say it may be, let's say 1, and new parameter again n, let's say it's 0.5. Basically we have to check this value. It's not fixed basically. We have to check for each and every replicate. So this is my value. Okay, so now we will go for apply. So when we apply, the model parameters have come. Now we will go to analyze. We will go for stress modeling, non-linear. Now in the X predictor formula, this KB model will come. So X predictor formula is KB model and intensity is in the Y axis. So it will be Y response. So it's okay. Now this is come. Clear? Now what we will do, we will simply go for go. See, the model has fitted. And we must always use the save estimate. So we will copy this value into our sheet. So let's say, so suppose I am copying it, Control C. So here I am writing K, here I am writing N. So I am copying Control V. So we will paste the K values and the N values. That is required basically for our own purpose. So here what we will do, we will simply do Control V. Okay, and what we will do is we will simply save the estimates. Okay, now to understand the correlation or calculate the R square value, what we will do, so first let me write here R square. Okay, so what to do is we will simply go to analyze again, multivariate methods, multivariate. So here what we will do, we will press Control and select all, like both of them, KP and I, because these two are the main parameters in the Y columns, and okay. So we have got this particular, so this 0.994 as 0.994 represents the R square value. So what we will do here, 0.9994. Okay. So we have got the plot, and now we can save this JMP file. Let's say save as, and then you can write any kind of a name and you can save it. So this is one type of data where already the minimum, where the starting point is already for the minimum value. Okay, now I will show another data where suppose this minimum value has started from little bit like later, like suppose this is your first time T1, in T2 your minimum value has come. So we will take the minimum point only. That is, we will start from the minimum point. Whenever we are talking about interpolation, we will always start from the minimum to maximum. Let's say. So in this case, what we will do, we will select 10 data points from the minimum. That is including the minimum. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, Control C. Then we will go to origin. Let's have a worksheet. This is the worksheet, new worksheet file. So we will go for this Control V, and then as usual we can go to analysis, mathematics, interpret, extrapolate, open dialog. So we already know it's a cubic spline. So we will uncheck this auto. We will do 100, and then the output, what we will do is we will go for new, clear, okay. Let's go for auto preview. So deviations are not so high, and thus this is an interpolation data. So this data we will simply copy and we will paste it, and then the procedure remains same. For like if we go for this particular thing, so we have to like go, okay. So this should be escaped, and then we have to copy it again, like right click, left position, and then we will simply paste it. So this is your data, and as usual, as I've already shown you, you have to plot data. Now these are actually the replicates. Like suppose you have 5 technical replicates. So how will you plot in that case? So this was my calculated value. Let's say I have already calculated it, like already I have calculated. So what to do in the next part? Like how will you calculate this part? So we have already calculated the JC1. So suppose this is let's say the sample 1. So the first replicate of sample 1 is this one. Now in order to calculate this k and n for the second sample, there is second sample replicate. Suppose we are having 5 samples, okay. Let's say A, B, C, D, E. Let's say this is the first technical replicate of sample A. Now in order to calculate the k and n of the technical replicate, there is a second technical replicate of sample A, we will have to use the k and n value of the first technical replicate. This is called the iterative fitting. So how will I do it? I'll just show you, like first of all I will show you from the basics. So let's say that this is our data, this is JC2, it is sample, let's say second technical replicate of sample A. So here we have already seen that this is a minimum value. So we'll start from here. So we'll start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have taken 10 values. So no need to worry. We will go to origin. So we will open a new workbook. What we will do is we will do Control V. We will select it. We will go to analysis, mathematics, and then we will go to interpolate, extrapolate, and open dialog. The same procedure. So we will again click on cubic spline. This is auto. This is 100. Okay, and new, clear. Now we'll go to auto preview. So it's not having lots of deviation. So we will go for 100, and then we'll go to OK. So what we will do is we will copy this. Let me uncheck this escape. Then we will simply copy it. Copy for triple precision. Then we will simply paste it here in this particular part. So what we will do is, this is your time data, this is your intensity data. So here equal to first is 0. Good. Then we will go for equal to this one minus this one to calculate the del t value. Okay, and then equal to this one plus again this one. Press F4 to fix the cell. Enter. Then double left click. Then the values will come. Similarly, equal to this one minus this one will give you intensity 0. Here you have to fix the cell. This is the upper cell. So we will do this one minus this. Again F4. And then this is the data. So we will do again, simply copy and then paste. So we will delete these 2 columns, no needed requirement. This is our data. So 1, 2, 3, 4, 5, 6. We will simply do Control C. Separately you paste it in another part of your Excel file, Excel sheet. Now with these 6 data points, we will try to fit into the Cosman plus 1 equation. What we will do, we have already seen. So I'll just start from the basics, start from the first again. So I'll just open a new file, new data table, and then we'll simply close it off. Okay. So again, what we'll do is, this is my T, double click, double left click, so small t, okay, then double left click, it will be capital I, and again double left click, it will be cubic model. So what we'll do is, we'll copy this data, so you have already pasted the data, so it's a data. Good. Now select this particular column, right click, formula. So we have got the 3 parameters in 3 columns. Now what we do, we have to input the formula, this k, capital K into bracket small t to the power n. So we'll here go to the drop down menu, parameters, new parameter, see k. Now we will refer to the Excel file. See, this is the second technical replicate of let's say sample A. So we will have to take these 2 values, that is the technical replicate k and n value of the previous one. This, if it is a second replicate, then we have to take the k and n of the first replicate. This is very important. And why? Because in order to increase the accuracy of a model, thereby this is called iterative fitting process. Iterative fitting process. So what we will do, here we will simply input like 0.555. You can copy the value also. Okay. Sorry, 262. Sorry, 262. And the next part, we have another part, new parameter, small n, how much? 0.784237. 0.784237. So okay, apply. It's already applied. Now what you do, you already know, go to analyze, stress modeling, non-linear, keep model building the expected formula, I will in the y response. Okay. So now what we will do, we will simply do go, and then therefore we will save this. So the same procedure, we will save the estimates, and then we will simply copy the k value and the n value in the next part. So in this way we can calculate the k and n values from the set of data points that we have got in the FRAP experiment, and our main motto is to model those data points in the Cost-Smart-Bebber's equation, so that in order to understand about the gel behavior and also about the other properties. Okay. So this is how we can model the FRAP data into the drug diffusion equation. Thank you so much.